that you're reading?
Oh, what do you ask, sir, fellow Brendan? I'm reading about some enzymes, like Rubisco, and this new one called, how do you say it? Big Quest C?
Oh, I do believe you mean Big Quest me.
Oh! Did you say Big Quest you?
Indeed, I actually invented Big Quest C. It came to me in the night as a dream. Let me tell you more. You see, sir, the whole thinking derived from my studies of an enzyme called Rubisco. Rubisco is a fascinating enzyme. It takes carbon dioxide from the atmosphere, as well as energy from light and water, and synthesizes glucose, which is used by the plant to grow. It also releases oxygen gas into the atmosphere. Do you understand, Father Jenkins?
I think I'm catching on, but could you explain it further?
I have just the person. Dr. Eckstein, would you please explain for Father Jenkins?
Oh yes, I can explain it. As you can see here, photosynthesis utilizes Rubisco to fix CO2 and in turn produce oxygen, which allows for the plant to grow.
Well done, young apprentice. However, what she did not tell you is that sometimes Rubisco is a nasty little rascal. He's supposed to bind with carbon dioxide, and therefore fix carbon for the plant to use. However, sometimes he binds with that forbidden fruit, oxygen gas. When he binds with oxygen gas, there's a net loss of carbon, and the plant actually loses energy. Please allow my apprentice to explain more.
Wait. So, what's the big deal?
When Rubisco binds to oxygen, it uses up ATP and NADPH, which results in a loss of energy from the plant, and in turn releases CO2 back into the atmosphere.
Yes, you see here, there was a great difference in the atmosphere compared to that of today. The levels of carbon in the atmosphere were greater in comparison to that of oxygen gas. There was far less free oxygen in the atmosphere for Rubisco to bind to, resulting in photorespiration, causing less of a consequence for the plants back millions of years ago when plants began to arise.
Indeed, Professor. Photorespiration wastes nearly a quarter of the carbon that plants could use for carbon fixation. However, we have solved that issue.
What? Do I hear there is hope yet?
Indeed, Big Quest C refuses to bind with oxygen gas, meaning that photorespiration will not happen, and the plant will not waste its carbon, meaning that my beautiful trees will grow in abundance. Wait, you mean to tell me that you have created an enzyme that on one hand will do photosynthesis and help plants to grow, but on the other hand will not lose carbon to photorespiration? Why, this could change the issue of carbon fixation forever.
By Jove, the implications are huge. Trees will become an even greater carbon sink, and this could help combat climate change by decreasing the amount of CO2 in the atmosphere because of the lack of photorespiration. This is a massive discovery. So what is this carbon sink you speak of?
Well, you see, Father Jenkins, a carbon sink is a system that takes in more carbon than it gives off. So, if a carbon sink increases, you could further help decrease atmospheric CO2 levels and combat climate change.
Well, I think I understand now. This is truly fascinating. This new molecule could revolutionize the world. Your minds have truly not been cultivated at the expense of your heart.
Indeed, this could potentially have a wonderful effect on carbon fluxes in the atmosphere. Well done, professors.